Buoyancy is a lifting force that some liquid has on a body, which is submerged in a liquid. In this example, I'll review a simple case which will be easily used to solve for many other cases. In this example, I have a tub of water, and this can be any arbitrary object. In my case, I'm using an egg. The buoyancy force is always directed upwards, and it's calculated by the equation force equals gamma times volume. Gamma is specific weight. Volume, this V, is the volume of the object which is submerged underwater. So there's two cases for volume. I can have an object like this, which is 100% submerged under the water, or I can have an object which is partially submerged under the water. And in this case, I'm only going to use this. The buoyancy force is not going to act on the volume which is out of the water, it's only going to act on the volume which is in the water. Gamma, the specific weight, is calculated by taking the weight of 1 square meter of the liquid. So it's really just weight per unit of volume. So the units of gamma are going to be newtons per meter cubed. The weight of the volume is going to be meter cubed. These are going to cancel, and they're going to give us a force in newtons. So in my experiment, I'll use the equation for buoyancy. I'll hold the specific weight as my independent variable. I'll hold a force as a dependent variable, and the volume submerged is going to be constant. I'm going to make sure that my egg is always submerged 100% under the water. So since specific weight is my independent variable, I'll change it by adding salt to the water. If I take this 1 meter cubed of pure water and I add salt to this 1 meter cubed, well, I added weight to that 1 meter cubed. So that's why the specific weight will be greater for salt water. So if initially I have an egg that sinks to the bottom and I increase the specific weight, therefore my force will be increased since my volume is constant. So, as I explained earlier, in pure water, the specific weight is lower than salt water because we have the added weight of the salt per unit of volume. So if I place the egg in pure water, or tap water, we see that the egg sinks to the bottom. So that means that the buoyancy force is less than the weight of the egg. Because you have the weight coming, the weight is pulling the egg down, the buoyancy force is pulling the egg up. So there's a greater downward force than there is an upward force. So the egg sinks in the water. If I come over here, where the specific weight is greater, the buoyancy force will be greater. So the weight is still the same. And you can kind of see, it's kind of hard to see because the water's cloudy, but the egg floats because now the buoyancy force is greater than the weight of the egg. So there's a greater upward force than there is downward force, so the egg comes up.